Hi, in this video we're going to find what's called the standard form of a parabola. And I brought this over from our last video. In our last video or lesson we graphed y equals x squared minus 4x plus 1. And we used an xy table and we found that it has a vertex of 2 comma negative 3. So what we're going to do in this lesson is we're going to write the standard form of a parabola and see how to use it. So we're going to use the same equation. So let's write this. Y equals x squared minus 4x plus 1. Okay, what we want to do is complete the square. Well, we could just leave it at that, complete the square. So here we go, let's complete the square. Now remember, when we complete the square, we're only working with the x terms. So the constant term, the term without the x, the 1, we don't want to work with. So right off the bat, let's just get that out of our way, and we'll bring it back in the end. So I'm going to subtract 1 from both sides. I'm going to write my problem now as, we'll write it minus 1 plus y equals x squared minus 4x. And then what we're going to do is we complete the square. So we've done this before. We take 1/2 of the term in front of the x, which is a negative 4. That gives us a negative 2. And then we take the negative 2 and we square it to get a positive 4. So the positive 4 is the result that we add to both sides of the equation. So really I have a positive 4 minus 1 plus y equals x squared minus a 4x plus 4. Now let's clean this up. We have, this is going to be 3 plus y equals, and now we know if we use this negative 2 that that's the perfect square value. So I write x minus 2 squared. Now the final piece is we get the y back by itself, so we subtract the 3 from both sides. And now I'm left with y equals, parenthesis, x minus 2 squared minus 3. Now, let's take a look at the vertex from above. And sure it is, there it is, 2 comma negative 3. Well, here's what you do. The vertex is you take the value in the parentheses and change its sign. So if we have negative 2 there, we change it to a positive 2. And then whatever this piece is here, the constant becomes our y value. So I have negative 3. And that, once you have the standard form, you know where the vertex of the parabola is. So you might say, well, why is that so handy? Remember last time we had to keep guessing where the vertex was. But this time what we could do is when we make our table of values, so let's come down here, let's graph this. If I make my table of values, I have x and I have y, I know that when x is 2, y is negative 3, and we can even check that. We could say y equals 2 squared minus 4 times 2 plus 1, which is going to be 4 minus 8, that's negative 4, plus 1 is negative 3, just like we would expect. But now we know that the vertex is either the highest or lowest point. So the entire parabola just begins at the vertex and then moves outward. So we know that the next point to the left we know is 1, and the next point to the right is 3. And then we know the next point to the left is going to happen at 0, and then the next point to the right would happen at 4. And we could just continue this process. And in the last video, that's exactly what we did. And so if I was at my vertex at 1, 2, 1, 2, 3, now I know that if I just pick values to the left, like 1, and pick values to the right, like 3, that I can find the next point in the parabola. And then my next value to the left would be here at the origin, which would be 0. And my next one to the right would be 4. And so it immediately guides your thinking if you know the vertex, which is why we want to write our parabolas in standard form if we can. So let's try another example. Let's try this. Oh, and you could graph this, but we already did it. We know the end result. The picture is right up here where we started. Okay, now let's try another example, and we'll see it in its entirety. So let's do this. We're going to write y equals x squared plus 6x plus 4 in standard form. And the vertex. And graph. Oops, that P looks funny. All right, let's graph. Here we go. So again, we'll write this down. We have y equals x squared plus 6x plus 4. The first thing we do is we subtract the 4 from both sides. So if I do that, I have negative 4 plus y equals x squared plus 6x. And then the term in front of the x, the 6, we take half of that, 1/2 of 6, to get 3. And we square the 3 to get 9. So this, I add 9 to both sides. So now I have 9 minus 4 plus y equals x squared plus 6x plus 9. Now we clean up. On the left-hand side, I have 5 plus y equals. On the right-hand side, we know that x squared plus 6x plus 9 is a perfect square if we use the 3. So we write this as x plus 3 squared. My last step is to subtract the 5 from both sides. Now I have y equals x plus 3 squared minus 5. And from that we can find our vertex. Our vertex is, we take the number in the parentheses and we change its sign. So we have positive 3 in the parentheses, so it becomes minus 3, comma, then we just take the ending constant, which is negative 5. That's where my vertex is. So let's do this. I'm going to grab some graph paper here so we make a really good graph. Paper, get my graph paper together. And let's make a nice graph of this. So, and we'll do this by design. So I'm going to move this up a little bit. So I have a nice, lots of space here. So let's see. There. And I know that most of this graph is going to be in the negative x values, so we'll just stop there. And then let's graph this. So negative 3, negative 5. Well, let's just start right there. So I go to negative 1, negative 2, negative 3. And y is negative, so this is negative 3. Negative 5, I go negative 1, negative 2, negative 3, negative 4. There's negative 5. So we go to where those meet. I put a dot, and that's the vertex. So what I know now is that the parabola just goes up from one side and up the other. But we even know more than that. All we have to do now is just study one side of the parabola, not both, because of its symmetry. So let's take a look at the left side. What happens at the left side? Let's look at the left side. So to look at the left side, I'd want to now consider what happens at negative 4. And the next point would be negative 5. And the next point would be negative 6. So let's see. Let's try those three values. So here we go. Let's make our table. Here's x. Here's y. So let's try negative 4. And we'll put that into our original problem. Y equals x squared. That's negative 4 squared plus 6 times negative 4 plus 4. So let's see. This becomes negative 4 squared. That's 16 minus 24 plus 4. That's going to give me negative 4. Okay, let's try negative 5 now. Negative 5. So y equals negative 5 squared plus 6 times negative 5 plus 4. So this is 25 minus 30 plus 4. That's going to be 1. And we'll try negative 6 as well. Negative 6 says y equals negative 6 squared plus 6 times negative 6 plus 4. So this is 36 minus 36 plus 4. That's just 4. So now let's graph our points. We have negative 4, negative 4. So I go to negative 4 and I go down to negative 4. So I have a point there. My next is at negative 5, negative 5, 1. Well, that's actually, I'm going to grab another color here because that is right there. Negative 5, 1. My next one, I go all the way out here to negative 6. And then I go up to 4. So 1, here's 1, here's 2, 3, here's 4. So you go to where those two meet and put another dot. And so look at what happens. We know that this is this point right here. This is the vertex. So we begin, just connect our curve here. Oops, I think I made a mistake. Negative 4. I did. This should be a negative 1. Yes. Oh, see my mistake? That should be a negative 1. So let's fix that. I'm going to put my dot there. Let's get rid of this line. Get my pen back. Okay. And now we can continue. Okay, so we have our graph. Looks like this. But remember what we know. We also know that because of symmetry, that if I imagine this green dashed line is the mirror, then I know that we have a mirror image on the other side of the line. So we'll draw our mirrored side in green. So notice that this dot here at negative 4, negative 4 is only 1 unit to the left of the symmetry axis of symmetry. So if I go 1 unit to the right, I get the other point. My next point here is at negative 5, negative 1. Well, notice that I'm 2 units from the axis of symmetry, so I can continue 2 units to the other side. There's my next point. And then if I go to the next value, my next value is at negative 6, 4. That's, look at that, 1, 2, 3 units to the left. So I know there should be another point, 1, 2, 3 units to the right. And there it is. And that gives us the other half of our picture. Also, I want to show you something here. This point where it crosses the y-axis, we call this the y-intercept. And where it crosses the x-axis here and there, those are called x-intercepts. And we'll be finding those shortly, but not today. Just so you start to hear the words, x-intercepts. Okay, let's try one more. We'll try one more, but I think this video has gotten a bit long, so we'll do that, the next example, in the next video. Thanks for watching.